Hey everyone, welcome. This is a second attempt to talk about SWMR for h5pyd and FancySelections for h5pyd. Last month there was a little bit of network issues. So let's see how it goes this time. Anyway, first I'll talk about SWMR. So SWMR is a single writer, multiple reader, and it was a library feature. It's a library feature that lets you do things like open a file for writing, and have a second process that's reading a file and then synchronize updates from the writer to the reader. And I thought it'd be nice to have the same API for h5pyd. Firstly, just because it's nice to be compatible and not have to make special cases for h5pyd versus h5py. And secondly, because it actually does work in a way to let you synchronize stuff, even though the mechanics behind that are pretty different for HSDS. So let's see how this works. I put a link in the chat to this notebook, so you can follow along at home if you like. This, again, is running in GitHub Codespaces. So you just click on the Create Codespace and go to this notebook, and you can run the example just as I am. So the SWMR example can run either with h5py or h5pyd. So let's first do h5py. So I'll set this use h5py to true, if I can spell. And run this. So we're going to do import h5py and set the file path to a local POSIX file. Okay. And then we're going to create this file. So it's write mode. And it doesn't matter for h5pyd, but for h5py, you need to use libver equals latest to use SWMR. Okay, so F is going to be the handle we use for writing to the file. And here I'm going to create, with F, I'm going to create a data set, make it extensible. And next, you set SWMR mode to be true. So this lets the library know that we'll be doing SWMR operations, possibly with one or more readers. Okay. So secondly, I'm going to create a additional file handle. Normally this would be in a separate process or a viewing program or something, but to make it easier, I'm going to do everything in this one notebook. So here, the G handle would be the same file path. By default, it's read-only, and you need to set SWMR equals true. So for the reader in SWMR, you have to initialize SWMR to true when you open the file. You saw here for the writer, we set the SWMR mode equals true after the fact, but that's not the case for the reader. So we create G. And now, if I look at that data set in the G handle, it looks just like we expect, 3x4. And if I print the contents, we see it's all zeros. Now going back to the right handle, I'm going to fill in some values for this data set. And if I look at through the G handle, we actually do see the values. So here's something I'm actually not quite clear on myself with SWMR. There is a method on the data set called refresh. Should you always use that? It doesn't hurt to use it, but I'm not clear actually myself when it's necessary. Jolie, do you know by chance?
No.
So here we'll do a refresh and then we'll get the same result. And here I'm going to resize the data set to be from 3x4 to 6x8. So again, with the right handle. And if I look at the data set through the read handle, it's also 6x8. And again, refresh doesn't hurt. And if I write an attribute to the data set in the right handle, we see it in the read handle. So A1 is in dataset G attributes. And similarly, if I create a group, we'll see this is true by the read handle. And then the files. Okay, so don't take my word for it about how SWMR works in every circumstance with the library. But this is kind of a baseline. And now we'll look at how h5pyd differs. Let me clear all outputs, restart. And here it sounds like use h5py equals false. So this time, we're going to open this file path. So in HSDS, file paths always have to be absolute. And here I have this HDF5:/ as a prefix. That just helps distinguish it's not a POSIX path we're talking about. So now I can create my domain, and we'll do all the same stuff. So, and set some remote equals true, get the read handle with the same SWMR equals true. And if I look at the data set, it looks just like what I have with the right handle. And if I look at the data, it's all zeros. We'll write some data. And we'll look at the data set data through the read handle. And just like with HDF5 library, we see the values. But it doesn't hurt to call refresh and see these values. So here's something a little bit different. If I resize the data set through the right handle, and I look at through the read handle, I see that I'm still seeing the old shape. So this is an artifact of how h5pyd optimizes calls to the server. When you open a file for reading, it'll pull in all the metadata, things like the dataset shape and type, links, attributes, and so on. So what we're seeing here is h5pyd looking at that cache data for the dataset shape. But if I do this refresh call and then look at the dataset, we see now it's the proper 6x8. Okay, so dataset.refresh will always synchronize your application with whatever state the server has. With attributes, I can create an attribute. And if I look at the read handle, it does show up. And if I create a group, we see that is also there. And just like before, we'll close the handles. Any questions about SWMR and h5pyd?
John, when you created the attribute and the group and you didn't need to call refresh to show it, is that because HSDS operates on this cache information first before hitting the server?
Right. Yeah, so if you set this refresh, it's going to wipe out the cache for that dataset object. And from that point, every time you look at it, you'll get the current values from the server. That said, it doesn't hurt to call refresh anytime you suspect there might be some changes on the server side. It won't hurt. And in some circumstances, I think it'll be needed for compatibility with h5py.
Okay, but in the last comment there, you have you don't need a refresh to see the attribute change from the
Right.
read-only handle. And
Yes.
so my question was, um, how do you? Is it because you make the change to the attribute before you update the server, and that's why it's current?
Yeah, let's actually, I think you do need that in some circumstances. Let me walk through this again. So we create the main server mode, get this, create a data set. There, these are already not needed. What I want to do is if I skip that and go down to create an attribute, I think this will be false. Let's try it out. No? Okay. Yeah, I'm not sure. I know in some circumstances these attributes won't show up if they are created or updated by some other process. I think it's when you set this swimmer mode equals true in the constructor that it's not utilizing this cache aspect for h5pyd.
Okay,
Okay.
okay.
I
So
maybe
there's
it's more unclear, but I guess my advice would be that anytime you absolutely want to get the possibly latest changes on a data set, whether it's the values or attributes or links, it doesn't hurt to call the dataset.refresh before doing your operation.
Yes, and I guess maybe we're also looking at everything being done within the constraints of one process, right? That's the way that your demo is set up here.
Right, right. Yeah, that's what I was thinking, that if I actually had a true multi-process demo, we might get different results.
Yes, because then we might see the differences in refresh
Mhm.
showing up upon when you change update attributes and things like that. Okay, all right,
Right.
that's good. Thank you.
Okay, so let's move on to this fancy selection. If I can see it. Oh, it's here. So let's walk through this. So fancy selection was actually a feature we added to h5pyd like a couple of years ago, I think. And there was a request in the forum for a more advanced kind of fancy selection. So let me just walk through how this works. Again, let's start with use h5py equals true. So we'll import h5py and have our file path be fancy select.h5 as a POSIX file. So first, let's see how this works with NumPy arrays. So NumPy arrays are kind of like HDF5 datasets, except they are a in-memory construct only. So if I do numpy.arange234, we'll create a three-dimensional array. And there it is. And we can do selections where I say, give me all the values in the first dimension, all the values in the second dimension, and these indices 0, 1, and 3 in the third dimension. Okay, so my data set shape was 2 by 3 by 4. So this result will have 2 times 3 times 3 elements. And there it is. Okay, in NumPy, you can also have multiple selection indices. So here, I'm taking all the elements from the first array, and then indices 0, 1, and 2 from the second dimension, and indices 1, 2, and 3 from the third dimension. So now I'll have 2 times 3 values. So it's not a combination of these last two set of indices. It's for everything in the first dimension, 0 and 1, and then everything in the first dimension, 1 and 2, everything in the first dimension, 2 and 3. We create a three-dimensional array in NumPy, and we can select things like everything in the first dimension, everything in the second dimension, and coordinates 0, 1, 3 in the third dimension, and we get this result. Or we can say everything in the first dimension and coordinates 0, 1, and 2 in the second, and coordinates 1, 2, and 3 in the third. So if I do that, I get 6 elements. Okay, I get this 1, 6, and 11 from the first index here, and 13, 18, 25 from the second set of values. Now let's contrast how this works with h5py. So I'll create a file, create a data set. We don't have chunks because we didn't specify chunks. The data set ID is numeric. And then I'm going to write some values into our data set. So here we're creating a data set that is 5 by 1,000 by 1,000. And what I'm doing is writing kind of this diagonal set of values. For each index in the first dimension, I'm going to write this 1, 10, 100, 1,000, 10,000, and so on. So if I do a normal hyperstep selection, say I get all the elements in the first dimension, and indices 4, 4, 4 in the second, and index 4, 4, 4 in the third, we'll get this. All right. So it's 4, 4, 4, 4,440, and so on. These are the 5 elements in the first dimension, and I kind of fix the second 2 coordinates for dimensions 2 and 3. You can do fancy selection in h5py as long as you only have one dimension that's using coordinate indices, and as long as the indices are increasing. So here I'm saying, give me everything in the first dimension. This is the next 4, 4, 4, and then indices 3, 3, 3, 4, 4, 4, and 5, 5, 5 in the last dimension. Okay. What you can't do is have the coordinates not be increasing. So here I have 3, 3, 3, 5, 5, 5, 4, 4, 4. It's the same indices, except I put 4, 4, 4, 4 in the last. This will fail. So it says type error, indexing elements must be in increasing order. You also can't do this. You can't say data set, everything in the first dimension, and this set of coordinates, and that set of coordinates. So you get this error. Only one indexing vector or array is currently allowed for fancy indexing. All right, so let's close the file. Any questions on how h5py and fancy indexing work? If not, I'll go on to h5pyd. You're all still there, right? Or not? Okay, good. Anyway, so let's use h5py equals false. So in this case, we'll import h5pyd as h5py. This little trick, so I don't need to change any of the other code. And our file path now will be a domain path. Okay, so we can skip this part because that's just NumPy. We'll create a HSDS domain, like so. And if I get a data set, we get our HDF data set. Here, just to show off the difference between HSDS and the library. In HSDS, data sets are automatically chunked. If you don't specify a chunk layout, one will be chosen for you. And in this case, we got 3 by 500 by 500. The dataset ID will be a GUID instead of an integer. And this part will work the same, except a little bit slower. And this normal high-risk selection will work the same as h5pyd. Okay. And then the fancy selection will work same as h5pyd. So we got the same result. And here we had an error, remember, when the coordinates were not increasing. But with h5pyd in this last update, that's not the case. And so here we got the same values, except the second column now is the last column. And additionally, you can have multiple coordinate dimensions. So here I'll say everything in the first dimension and coordinates 110, 100 in the second, and coordinates 110, 100 in the third. We get this. All right, so it's a little bit of enhancement over h5py. Like I said, the person in the forum thought this useful, and it turned out to be quite a bit more work than I anticipated, but I'm glad we got this feature in. So any questions on selection? If not, I'll open the floor to questions on anything. Okay. Well, if no questions, thank everyone for coming, and I'll catch you next time.
All right, thanks, John. Bye-bye.
Really.